Good morning, and thank you for joining us for the second day of our digital HPC Roadshow. Once again, my name is Chris Coetzee, and I'm Country Manager for Boston Limited South Africa. I'm really looking forward to the day ahead with keynotes, content and training from our partners and leading industry vendors. Before we go on, I want to take the opportunity to thank our event sponsors. I'm sure you'll agree we've had a great first day and there is more to come. So thank you to our Center of High Performance Computing, Supermicro, AMD, NVIDIA, Vscaler, and the Boston Trading Academy. Without their support, this event won't be able to happen. I'm honored to welcome today Dr. Happy Sithole. He's a director for the Center of High Performance Computing in South Africa. He will be giving a keynote today and speaking about the state of HPC in Africa. But first, this session's password. Attendees who provide at least 7 passwords by the official close of our event can unlock training given by the Boston Trading Academy. That's taking place Friday morning, the 2nd of October. This morning's keynote password is excellence, which I think is very fitting in reference for today's speaker. As a reminder, we'll also be undertaking questions at the end of the session. So without further ado, I'd like to hand over to Dr. Happy Sithole.
Thank you, Chris, and good morning, everyone. It is my pleasure to be here, joining you and giving you this keynote. As Chris has already indicated, my role is the manager of the National Integrated Cyber Infrastructure. So I would like to take you a little bit through what the National Integrated Cyber Infrastructure is. So this is an area that looks at high performance computing requirements in South Africa, large data repository, and we also look at the broadband connectivity. Our role is mainly working with all the researchers in South Africa, the researchers here being in the universities, and we have got 26 research universities in South Africa. That depends on this infrastructure. We also have got the role to support the African countries. We have through the Square Kilometer Array, we have got 8 partner countries that we also support with cyber infrastructure. And mainly our SADC countries under the SADC Cyber Infrastructure Framework, they also depend on our facility. So today it is my pleasure to introduce you to our facilities. And as the title of my talk indicates, I will be giving you an update of the status of high performance computing in South Africa and the continent at large. So before I dwell deep into high performance computing, I will also give you an update on the connectivity in the country, because that's very critical. If you have got one infrastructure that so many people depend on, connectivity becomes a very critical component for the success of such infrastructure. So we have in South Africa started investing in cyber infrastructure since 2006. So I can safely say now we have been 14 years in cyber infrastructure. And the cyber infrastructure is supported by the Department of Science and Innovation of the South African government. So we are a fully funded facility, and we are supposed to provide the resources to our users. I don't want to say it's for free because our users use this. They don't have to pay us any money, but they have to demonstrate success. And success in this case will be on their outputs in terms of their research papers, graduating students, and also making sure that they make impact in some of the socio-economic aspects of the country. And I can talk a little bit about some of those areas of research that utilizes this facility. So since 2006, the government supporting the infrastructure. So basically when we started, there was no high performance computing in the country in terms of a facility. There were a number of processing capabilities at various institutions, mainly managed by the professors. And as you can see, if this facility is linked with a research grant, the issues of sustainability are quite high there, because if the grant finishes, then you have quite a challenge. If the professor leaves the university, then you have got a challenge. Again, you find that the other challenges that we had there was that these facilities were managed by grad students. If the student graduates and does not want to stay in research, then you have got challenge. So I think overall, then we can see that we had challenges in terms of the infrastructure sustainability. Hence, the government took a cue out of this and looked at what other countries are doing to invest in this central facility. And when we started off in 2007, we deployed our first machine. And the machine that we deployed was an x86 system. It was IBM machine. It was based on AMD processors. So we got that machine, and it was basically when we go out and say, we need a supercomputer. We have got the money, and we put the money on the table, and they said, this is the supercomputer. I've got the issues of how do you sort of support this system. You don't have the right skills in the country, and you have to depend on the OEM capabilities, which mainly at that time were not even in South Africa. I can tell you the guy who was supporting our system was sitting in the UK at that time. So, but it was a good start in a sense that even though it is not ideal, through that we managed to make sure that after the installation of our first cluster, we identified what we called the flagship projects. And these flagship projects were linked with the key strategic areas of the South African government, which was mainly aligned with what we call the 10-year innovation plan. And those were in the energy security. You were looking at the climate change. You are looking at the geographical advantage, and you are looking at the farmer to farmer or the bioinformatics area. So we selected our flagships amongst those. And out of that, we managed to demonstrate that if our researchers get the HPC resources, they can do better. For an example, if we look at the energy sector, which is energy security, one of the key areas in that was looking at renewable batteries. So the renewable batteries in this case, it is a simulation of atoms or materials at atomic level. And for you to be able to represent that system of the battery well, you need to have a large sample of atoms. And as you get a large sample of atoms, then you really need massive processing capability for you to be able to accurately be able to predict the properties of that battery material. So we work together with these researchers to demonstrate that they can be able now to get much better results. And these were linked at that time with what we called the battery vehicle in South Africa, which was called the Jewel. And there was a very good experiments and a prototype of a vehicle and the simulations which were done in there. So this was a very nice experiment that could be able to demonstrate value to the South African government. And we had a very short period because, as you know, the funding in government, you are given funding every year, and they would like to see the results in that year. So we had to really push very hard to make sure that these projects, they demonstrate value. So in that year, we managed to be able to show that we can be able to do better prediction of battery materials. Another very good example, which was linked with our geographical advantage, you might be aware of the square kilometer array. So at that time in 2007, South Africa was still in a process to lobby or to campaign to host the square kilometer array. So for them to be able to convince the world that you can trust the continent of Africa to host the square kilometer array, a number of other things have to be in place. And one of that was that, do you have got computational facilities? And that was one question that we had to answer all the time. Do you have the processing capability? So we also looked at this to say, are we having any scientists who will be able to add value in the square kilometer array? So that was two-pronged, and we worked with some of our scientists to design the SKA dish. And in this case, because for the SKA, the electromagnetic radiations or electromagnetic interference are very critical. So the design of the SKA dish, we looked at modeling the electromagnetic interactions and the shape of the dish. And we used that with one of the codes which was developed in South Africa. And we managed to look at how the shape of the square kilometer array dish will look like. And that was one of our flagship projects. So basically looking at this, and I guess that it gives you a good example of what we had to go through. So it was not only these two projects, we had one that was looking at climate change, and we had to look at having a regional model, which before the whole of the continent could not be able to do that. So we had other good projects which were looking at the bioinformatics in this case, and we had a project that was looking at the mutation of HIV, HIV virus. So in that, this built a very good case for the South African government to say, this is a good project to support. And we were then, in that case, moved into being supported not only year by year, but now over 3 years. So I guess out of this now you can see the strategic importance of high performance computing, what we have to go through to get into the country that did not have any supercomputing, and to be able to get them to a point where they can be able to have a long-term vision of investing in high-performance computing. So the first was the use of high-performance computing. I'll tell you, in 2007, we had about 15 users. Today, we are talking a couple of thousands of users who are using the high-performance computing in South Africa in various domains. We have got all scientific domains, computational fluid dynamics or computational mechanics. We have got material science, chemistry. We have got climate change. We've got also from the bioinformatics. So all these areas in all our research institutions. We also have got the industries also. And with the industries, they don't give us research papers and they don't produce students. So we work with them on the cost recovery basis. So I can say we are at a stage where high performance computing becomes very integral to most of the research institutions and also to the industries. So we evolved from the system that I talked about, which was 2.5 teraflops. And today now we have got an HPC system, which is now 1.5 petaflops. So this has been a very big jump, but this machine is not sitting idly. We had to grow organically. We had a couple of machines over that period, and all these machines, one of the key things that we're looking at is that the machine is built fit for purpose, and also we ensure that it is properly utilized. So our machines are close to 100% utilization by the South African researchers. And I said at the beginning that one of the key things that when we started was we just wanted a supercomputer. So we just went out to the market, we got the supercomputer. But over that period, we have evolved. And we have evolved in a sense that whenever we purchase a high-performance computing system, we do our homework first. So besides running the production HPC systems, we run what we call the Advanced Computer Engineering Laboratory. This is a unit within the CHPC that does research on novel architectures. So architectures which are, I would call, at the bleeding edge, which have not been generally available. This team here looks at those architectures at a small scale and bring in our users to test how suitable will it be for our user community. So we do quite a lot of that, and that is handed over to our researchers, and when it is ready, that's what defines our production system. So now we can call ourselves smart buyers of high performance computing because we do our own research, and by the time we get to the point of purchasing, we also have got our own ideas in that area. And we are very grateful to work together with OEMs and integrators like Boston, all the OEMs. They work together with us in that. We don't invest our money on the testing. We get access to the HPC systems of the OEMs. We have been working with Boston and also giving us the access to their systems so that we can be able to do this early testing. So the ecosystem between the national facility and the OEMs is very important. And we can't be able to do this all by ourselves. We work together also with our research community. So when we build a smaller system, we work together with our research community because our research community's view is very important to us. It tells us what is it that we need to do. So those are very important frameworks of having a sustainable HPC ecosystem in the country. And looking at building the relationship with the OEMs, with their local partners. When we started off in 2007, I would say our local representatives of IT industry, I used to call them the people who fill out the tender forms. Because mainly if you go and ask these companies, what does your personnel do? Do you have any of the engineers who understand the system that you deploy? They were not there. So we had to really work together with the OEMs to say, whatever technology that you deploy, we have to get people trained with your local partners, with our own system administrators and the engineers. In that way, we have got the local support. And I think after that, you could see that that has grown now. We have got a number of OEMs now having their representation in South Africa and also having the capability of HPC. So I'm quite excited also to see that Boston also bought into this idea. They have got their own now representatives in South Africa who can understand high performance computing and be able to support this. And this is what we are looking at. So moving on with our strategy also, one of the things that we are looking at is that for our own sustainability, a lot of people in high performance computing are the people who came into research and they required a high performance computer. So I would say it's a brigade that has been mainly self-taught people. And those people, I would give an example with myself. Coming from material science, I needed a supercomputer for me to be able to simulate large materials. And for that, my desktop was useless. So I had to build something bigger. And I learned to build clusters because of that. I did not have a lot of money, so I had to know about the clusters. So a lot of things were all self-taught. So we don't want to perpetuate the very same thing. And hence now we have got a program where we're looking at, we want to entrench HPC skills at the university level. And through this, get at the undergraduate students to learn high performance computing. And for this, we have started what we call the Student Cluster Challenge, where we get students from second year coming from your computer science, various sciences and engineering. And the students in here, they are taught how to build a small cluster right from scratch, and they are given the challenges to run real applications So basically they learn right from the architecture point of view. They learn the financial aspect because they are given a budget and say, here is a budget, go and design a supercomputer. And we have seen out of that very interesting design because you have got budget limitation. They understand that you need a lot of processing. So some of the students go and buy a lot of CPUs or processing units, but forget to buy network, or some forget to buy memory, some forget to buy network, storage. And at the end of the day, the students then they start realizing that you have got the finance, you have to understand to balance your architecture in such a way that it will be able to do the work. It must be able to have the processing capability. The processors must be able to communicate. You need to be able to store. So they understand now all the subsystems of an HPC system through that. And not alone only from the architecture point of view. They learn that now after you build that cluster, you should be able to understand or to make sure that it can deliver meaningful work. It must be productive. And with this, we give them real life applications. And I can proudly say that since we started with this program in 2013, South Africa has been doing very well internationally, winning gold. Our teams, the worst position they have been was position 3, but almost they have been in this competition 7 times, 4 times coming number 1, 2 times coming number 2, and only once coming the 3rd position. So out of 7 occurrences, they have been doing very well against the leading countries in high performance computing. So that taught us one thing, that we can be able to build our own skills if we expose the students to the technologies, give them opportunities, and the students can be able to do very well. So this is one of our anchor projects that we work with in building our capacity in South Africa. I think lastly, what I would like to address is that South Africa is not an island, so we can only succeed if the rest of Africa also succeed. So with that, in my opening, I talked about the square kilometer array and the 8 partner countries. This vision played a very key role in us winning the bid for the SKA, because our vision was that the SKA will be able to give you the southern clear skies, which are not tampered with. We have got the big Karoo, but also we are not just focusing in the Karoo. We can extend our view to all the way to Namibia. We can extend our view even to Ghana and Kenya and the islands like Mauritius and Madagascar and Botswana. So in that way, it gives you a broader picture of the clear southern skies by covering the rest of the continent. So that was a very compelling business case. But then one of the key challenges after we have made this business case was to make sure that we talked about these countries. They did not have any high performance computing capabilities. Now it is the responsibility of South Africa to make sure that these countries have got the skills for high performance computing, because the data that they will be producing from their own countries, we want them to be able to participate in ensuring that they also know how to process this data. They need to be able to come up with the scientists in their own universities who will participate in the SKA. These scientists should not be sitting there and being spectators. So for this, we build capacity in the African countries which participate in the SKA. We have got a novel idea where we look at the close to retirement supercomputers. We repurpose them. Through this, we train the system administrators first to assemble the supercomputers themselves, then from there to be able to load software, configure these systems, and also manage the high performance computing. And over and above that, we identify areas, excuse me, areas within each and every country that can be able to use this high performance computing system. So with that, we have got all these countries that participate in the SKA now, having the capabilities of high performance computing and also having like smaller systems in there. And this also extends to the SADC countries. But then over the period, we have seen that there has been now a growth in high performance computing. And this was even outside the countries that we supported personally, like countries like Zimbabwe now. Now they started building high performance computing systems, and we have been playing an advisory role in that. We have seen countries like Senegal now working together with other OEMs, building their own supercomputers. So I can say in the rest of the continent now, there is this growth. There is now the understanding that high performance computing will be important. But I think what I would like to conclude with is that for me, it's not just the shiny metals that interest me of having countries having high performance computers. For me, it's about what do they do with those high performance computing systems. And this is one of the things that I am personally carrying in around the continent, to say we need to understand what is the business value of high performance computing. What are the applications areas? How do they link with the competitiveness of each and every country in Africa? So this is the second phase that I believe we have to go through to make sure that Africa realizes the value of high performance computing, and we can see African countries being very competitive. So I would like to end this here by saying it is very good for you to be joining us today, and trust that with all the talks that you will be hearing and the expos, you will be able to see what are the trends of high performance computing, and it will also help you in your area of application. I'd like to thank Boston, Chris, for inviting me, and the colleagues, and wish that your roadshow will go very well. You will be the evangelist of high performance computing in Africa and help us build these capabilities around the continent. Thank you.